Okay, so I got a snapper that has cranked flawlessly for 15 years, and then it started getting hard to crank, and then it wouldn't crank at all. Um, but once it did crank, it worked fine. So that kind of tells me it's not a fuel problem or a compression problem. It has to be something about the ignition, getting it started. But once it's started, it's fine. Now, what I've done here is set up a circuit with my multimeter, and you can see that I have the black wire going to some alligator clips, and I have that grounded to the engine, and then the red wire is going into the spark plug cap. Now, I don't know if you're familiar with how this circuit works, but the first thing it starts off with is a magnet. And you can tell that pretty strong magnet there. And that magnet goes across these wires right here. That's a coil. And when you get a change in magnetic field across a coil, you get current. So I'm going to see what happens. I would expect I would get several hundred volts when I move this flywheel in front of this magnet. Okay, let's see what happens. I'm going to move the flywheel. And I do get some voltage. You see that? And it's proportional to how fast I turn this. If I turn it just, oh, the light's kind of in the way. If I turn it just a little bit, it goes up, not much. If I turn it real fast, it goes faster. So, looks like the circuit works. Now I did a little bit of research on this here coil. Turns out it's a solid state coil, which means there's a transistor in it. Which means that transistor is like a switch, and it will only trip when this flywheel is going 250 revolutions a minute. It works out to be about 7 revolutions in a second, so that's kind of fast. And look what I found in here. What could this be? I found this after I looked up the article about the magnetron, which is the solid state coil. So let's get the flywheel and see what that's all about. What happens when I pull this flywheel? See that little tooth that comes out? Tooth comes out. One of them's missing. It was in there in that bowl. And it creates the torque necessary to turn that flywheel. But the problem is that there was a little plastic post that kept this fin, from going back too far. You don't want it to go all the way back. You want it to stay like this so you get the maximum torque. And the other one, the pin broke and it just came out of there. This one, I just barely touched this little plastic post that was here and it just fell off. And the reason is that this is over a hot motor, and over time it deteriorates. Okay, so I went up to the hardware store to get this part that was broken. And I found it very interesting that they had that part in stock. They said, would you like this part? And I said, well, I'm going to all this trouble. I think I just want to get the whole new assembly. So they ordered it for me. And here's the unveiling. Briggs and Stratton. Let's see what we got here. Oh, what's this? I thought I would just pop this on and I'd be done. There's a brand new assembly here. That's interesting, isn't it? And here we have the assembly, but it looks a little different now. This is really pretty cool because there used to be a plastic post like a millimeter in diameter right there, and that's what broke off. But now we have a different mechanism. Look at how this works. The fins come out, and we have these huge, robust pieces of plastic that keep them in the proper place. And here's the most ingenious part. You put this cap on. Watch this. You see, the fins go through a hole in that metal plate, and that provides 1,000% more secure a more secure way to create the torque than the other method. And I would have never found this out if I had gotten that other part. This will never fail. So hey, hats off to the Briggs engineers. This is a very interesting design. See how it retracts back into the hole? I mean, that's much better. So I think what's going to happen is I'm going to have to take off this old metal bowl, which only had indentions, not holes, and put this in, and I will be able to get to the proper RPM to get that transistor to trip. And if that happens, I think I'm going to get massive voltage coming out of there. Okay, so first thing is we got to install this. And I've got just the thing to do this. So this is a 1-inch socket. And as we can see, it rotates, so okay, I gotta okay, so that socket that I need to get that mold off the flywheel, it's kind of a weird size. I thought it was a 13/16, and then that was too small. Then I got a 1-inch, and that was too big, and it turns out this is the size you want, 15/16. And then I got my problem figured out about this thing rotating when I try to remove the bolt there. I got some vice grips, and I just put them on the flywheel, and then cinched it down, and then you can just let the pressure go against this part of the motor, and that should allow you to take this bolt off. Okay, so I installed the new flywheel, and it seemed like there was more voltage coming out, but it didn't fix the problem. So back to the laboratory. Okay, so I'm back to where I started. I've got the shroud off. There's obviously something wrong with this coil. Now, you see where that blade pedal is? There's some federal mandate that you got to have this kill switch so that if you don't have pressure on that, it'll stop the engine by preventing the coil from providing spark, and then you're supposed to not have a finger lost in an accident. Now, if we go in here, I'm going to put my probe right there. You see that? Look at that. That's insulation right there. That black, and there is no insulation right here. See, that's all exposed wire. So what I think is that this kill switch is being grounded by the engine, and that's the problem. I'll try to get closer so you can see that. See that? That's all exposed wire right there. So I'm going to take a look at that and see if that's my problem. Okay, look at this. You see all this exposed wire? I'm almost certain that this thing's being grounded somewhere. It's touching the engine and grounding out. See all that exposed? So I'm going to get more light on it. And it goes under the coil, and I've unplugged it. It's been unplugged right here. And it was, in the previous video I showed you, this had some problems too, but it's all this scraping underneath here that over time has taken off all the insulation on the kill switch. So let's see what happens when I do a test on the coil without the kill switch. Okay, so I've disconnected the kill switch from the coil, and I'm going to put the shroud back on and see if it starts. Okay, so I disconnected the kill switch, put on the shroud, and it still didn't start. And everybody I've talked to says that means that the coil is bad. So I bought a new coil. So let's see what we have in here. We have the coil. And it comes with some instructions. And it comes with this card. Now this card is pretty important because that's what you're going to use to space the coil and the magnet. It's about 0.25 millimeters, and it'll be a perfect spacer, so we need to keep up with that. And here is the new coil. Now I'm really curious to see what the primary and the secondary coil readings are on a brand new one. Anybody that doesn't know how this works, there's two coils. The primary has a bigger wire that's kind of maybe 100 windings. It's not that many windings. And then there's a second coil called the secondary that has very thin wire, like your hair almost. And there's thousands of windings on that, I would guess. And the idea is that when that magnet goes over the primary, it's going to create a magnetic field that will induce a current to that secondary winding that has thousands of windings of very thin wire, and that's what gives you your spark.
Now, when I checked mine that's on the mower now, I had about 5,000 ohms for the secondary and about 5 ohms for the primary. So I thought the primary was bad. So let's just test the primary. And the way you test the primary is there's a little tab here, and that is the move this out of the way. That's the kill switch. And when this thing's grounded, the coil will not work. So that's why I disconnected it, so I could eliminate all the safety features that they have to turn the mower off. And so I'm going to connect this to my positive of my voltmeter, and I'm going to turn my voltmeter on real low because it was only 5 before, and I'm going to measure it, and oh, that's interesting, it's almost 0 ohms. Oh, I have it set at 1,000. Let's put it at 1 times. And I have about 6 ohms here, and I had 5 in the old one. So now, let's remove this, and let's check the secondary coil. Put this here. You just touch anywhere that's metal on this to make a circuit. So I need to take this down to 1,000. Now that's interesting. I've got 10,000 ohms here, and on my old one it's 5,000. So maybe that's the problem. So we're going to install this new coil and see what happens. You know, maybe this was my problem all along, because I still have some ohms coming through my coil. I mean, it's a little different, but it's not like a complete failure. But look at this. This is like when I started working on this, it's almost non-existent. I bet you this is, well, if this was true, then I guess the test where I pulled this off, it wouldn't fire, but that is messed up. Okay, what I've done is I've grounded my spark plug to a bolt on the motor, and I want to see with my new coil, do I get a spark? Let's see. Let's put this a little bit. Here we go. It's a sparking, but it's yellow. Probably need a new spark plug. But I think that was my problem. Okay, so the little connector that was on the shut-off switch was just so brittle that it just fell off. So I soldered like an extension wire to this, and it turns out that flywheel cup makes a really good soldering iron stand, so I think I'll use that. But you can see that I have soldered the new connection, and what I'll do is just use a twist-on connector. But you don't want to fool around with not having a cutoff switch, because that's a real serious safety feature. I mean, this would probably start without that connected,
but I don't want to take the chance. I want to make sure I have that installed. So we're going to put it on now.
Okay, so I'm putting on the coil, and I've got my magnet set right here, and I've got my kill switch. I soldered a wire to there and put this quick release connector on there, covered it with some tape so it wouldn't ever ground out. And the trick to this is it comes with the new coil comes with this card, and it's about the width of a business card, and you put that between the flywheel like that. You want to make sure this magnet's not there, because what you want is for the magnet to do all of the work for you. I've got this, see how it's free? And when that magnet touches it, it's going to do all the work for me as far as setting the space. So you make sure you keep the card between. There. And that's the space you want right there. Just let the magnet do the work for you. We're going to tighten that up. I'm not putting any force on it. I'm just letting that magnet pull the coil to the proper distance. Now I want to cinch it down pretty good. There. Then we'll just plug in the spark plug and see what we get. So now, what I like to do now is just sort of let the flywheel do the work of moving that card out of the way. Yep, there we go. Okay. All right, let's see what happens. Got the new coil, new flywheel. Make sure it's
I love it when a plan comes together.